Alright, it's Mr. Rops here, and today we're going to look at three equations and three unknowns, which is a scenario that looks something like this. And so, I always talk about the visualization at first. Well, I have three variables, three unknowns. I'm going to go to three dimensions then. And so if you can see from this, I have my XYZ axis. Here is my first plane, and that is what these graphs are. I can see the plane here. I can look that up from the top. There's the top graph. It's red. If I add on the blue one, I can see the blue graph now. And they intersect here, the blue and the red, on a line. And finally, I'm going to put the yellow graph on there. And you can see that they all intersect at a common point. And it is right there, the point, right here. And if I show it here, here's a point, -2, 0, 1. And so three planes can intersect in a point. They don't always have to, but for the ones that we're doing, they're always going to have a nice answer like this. So the visualization is three planes intersecting. I'm not even going to try to sketch this at a point. Okay, and so I can see from here, I believe the answer is -2, 0, 1. If I go to my calculator, it's going to do it for me. I'm going to go to apps, and I'm going to go to polysimultaneous 2. And then I'm going to go to simultaneous equation solver, which is number 2. But today I have three equations, and I have three unknowns. And so then I'm going to go to next by hitting graph. And I enter in the coefficients, so 3, 2, -1, 7, oh, -7, -7. I get 2, -3, 1, -3, and finally 1, 5, 5, 3. Now at this point, you should pause the video and be doing this in yourself into the calculator. And once you have all the values in, make sure this actually turns out 3, because if you forget to hit enter, it remains a 0. And then I'm just going to hit solve by touching the graph button. And again, I can see that I have verified it here. So that's technology's way of doing it. We can get nice answers really quickly. But if we have to do it algebraically, we have to. What I'm going to do is I'm going to give you kind of a system just to clear the clutter away from the work we do. And so initially what I'm going to do is I'm going to try and take equations and break it down so that I have like just two variables, like x and y and an x and y, two equations, two unknowns, because that we know how to deal with. So if we take our equations here, if I look at these first two equations, 1, 2, and 3, I can see that if I add the two equations together, I will eliminate the z's. So if I take my first equation, plus 2y minus z is equal to -7, and a 2x minus 3y plus z is equal to -3. If I add these equations, I get 5x minus y, and this is the key. I eliminate the z. That's key. -z plus z gives me 0z is equal to -10. I'm going to call this equation 4. And so now I want to get another equation with just x and y. And so what I can do is I've used 1 and 2 already. I'm going to use a different pair. I could use 2 and 3, or 1 and 3. And I'm going to use 1 and 3. Here's number 3, x plus 5y plus 5z is equal to 3. Now, I want to eliminate z because I eliminated z here. And so in order to do that, I have to multiply this equation by 5. And so every term gets multiplied by 5. So it's going to be 15x plus 10y minus 5z, and this is the key one. I want them to be opposite in this, be at the same. And then 5 times negative 7 is negative 35. And so now I come along and I add my equations and I get 16x plus 20y. Happily these cancel and I'm left with negative 32. And so now I have this I'm going to call equation 5. And so now I have a scenario which I'm very comfortable with because I did this lots in grade 8 and grade 9. I want to eliminate one of these variables, or I could do substitution. It's up to you. I'm a big fan of elimination when I'm doing these. But one of the things I notice is that these are all divisible by 4. I'm going to make it smaller by dividing everything by 4. So I get 4x plus 5y is equal to negative 8. And so the numbers are just a little bit more easier to work with. And if this is going to be my equation 5, if I take a look at this, I could multiply this one by 5, and I will be able to eliminate the y's. So when I multiply by 5, I get 25x minus 5y is equal to minus 50. If I add these equations up, I get 29x is equal to negative 58. Dividing by 29, I get x is equal to negative 2. Then I go backwards to try and find the other ones. I can use either equation 4 or equation 5. I'm going to use 4. So it's 5. I plug in the x minus y is equal to negative 10. Negative 10 minus y is equal to negative 10. Minus y is equal, subtract this over, I get 0. Y is equal to 0. So now that I have x and y, what am I going to do with these x and y?
You're going to plug it into the equations up above to get the z value.
Exactly. Do you care which one you use?
No.
Exactly. So I'm going to use the top one because it's on top. So 3x, I remember, was negative 2, plus 2y was 0, minus z is equal to negative 7. So negative 6 minus z, because this is 0, is equal to negative 7. I add the negative 6 over, so I get negative 6 is equal to how much? Or negative z is equal to?
Negative 1.
Super. And so z is equal to 1. So now I put it all together, and yes, I do have negative 2, comma 0, comma 1, which is equal to x, y, and z. Alright, so this is pretty messy algebra, and you can see that my answers are all the same as what we got from technology. But the key is you take two equations, eliminate a single variable. You take a different set of equations, and you eliminate the same variable. You have two equations with two unknowns, but you've eliminated the same variable. It doesn't always have to be z, but you have to eliminate the same variable from each one. And then this is a scenario that you dealt with in grade 8 and grade 9. Two variables, two unknowns, two equations, two unknowns, and then you solve them backwards. We will do some of these in class, but it's really good that you get a handle and good practice of it. I would like you to try this one at home before you come to class. Try it on your own, see what the mess you come up. You can check it with Poly Simultaneous.